Okay. Happy New Year, everyone. And let's solve another LeetCode problem. I have already copied everything. Okay, give me a second. I need to also choose the correct layout. And then I need to set the timer. Let's go. So the problem is called Koko eating bananas. Okay, so we have piles, which is a list of integers because it's account for bananas in each pile. And there is also age, which is an integer amount of hours to wait for the gods to come back. Koko can decide her bananas per hour eating speed of k. Each hour, she chooses some pile of bananas and eats k bananas from that pile. If a pile has less than k bananas, she eats all of them instead and will not eat any more bananas during that hour. Koko likes to eat slowly, but still wants to finish eating all of the bananas before the gods return. Determine the minimum integer k such that she can eat all of the bananas within h hours. Okay. So we are returning integers. And first of all, let's consider a corner case where we don't have pile of bananas. Let's say that this is impossible and we always have like at least one pile of bananas. Now let's say we have 6 bananas. And we have 1 hour. Okay, that's clear. It's 6. So, oh, sorry, 1. So, no, 1 hour. In 1 hour, she will eat 6 bananas. So we need to eat 6 bananas per hour to finish all the bananas. But let's say we have 2 hours, then it will be 3, and etc. Okay. So now let's talk about something trickier. Let's say there is 5 and 1. Let's now say there is just 1 hour. I think we have encountered another corner case. It's actually impossible. So I don't know what to return here. Let's assume that it's always possible to eat all bananas. So let's assume that h is bigger than length of piles, bigger or equal to. So at least you can eat a pile of bananas each time. So this is impossible. Let's say we have 2 hours. So then we need to eat 5 bananas per hour for that. Let's say we have more than 2 hours. Let's say we have 3 hours. Then we will eat 3 bananas, then 2 bananas, then 1 bananas. So it's 3. Okay, so let's think about the solution. One thing that comes to mind is, let's think about a brute force solution, right? So brute force solution is to try all the possible numbers between the smallest number of bananas that we can eat in an hour, which is probably 1, or the smallest pile of bananas that we can eat, and the biggest pile of bananas that we can eat in an hour. Okay, actually, no, the minimum value will always be 1, because theoretically, if we have more hours than bananas, then the minimum integer k such that we can eat all bananas within each hours will always be at least like 1. So choose between 1 and max of piles, and basically try all the possible values, right? So if we try all the possible values, how do we try it? What do we need to do each time? So for each of the piles, we just need to divide it by this number that we are considering, number k. Choose k between this. So divided, it's one operation, and then we will need to do it for each of the piles. Let's say there are n piles. So if we do brute force, it will be O of n multiplied by max. Okay, can we improve that? I think we actually can. So what I can see here is monotonical kind of thing, that if k equals, if k works, so basically if we can use k and we will eat all bananas within 8 hours, then k plus 1 will definitely work. And if k doesn't work, then k minus 1 will also definitely won't work. So we need to find k just exactly in the right place so that k plus 1 is, so that k is sufficient, but k minus 1 is insufficient. And that tells me that it might be a binary search problem. So we will try to implement binary search today. And then binary search for k. Basically choose k. Let's say try k. If sufficient, try a smaller one, else try a bigger one with borders of n in max piles. Okay, so I think that gives me an idea, and then it will be of n times log of max of piles. Yep. The runtime. What about space? Oh, 1, because we are not storing any new information anywhere. We just need to keep track of 2 pointers and calculate the middle one between them. So let's do implementation. Okay. So let's choose small and big pointers. It'll lower upper bound. L up, LU. Yeah, let's choose LU. And L will be 1 and U will be max, max of piles, but we want to do +1 so that the binary search works correctly, the binary search that we have in mind. Okay, let's define a function, check if k works, and this will be dependent on k, and total hours equals we start with 0. Then for pile in piles, we do total hours plus math ceiling of pile divided by k. So if it's a round number, it will be just round number. Otherwise, we are calculating the total number of hours that we need, because even if there are some smaller pile, we still need to spend the whole hour. Okay, so then return this total hours is smaller or equal than h. Okay, so now while L is smaller than U minus 1, we calculate middle between them, and let's calculate it in a reasonable way, which is L plus U minus L divided by 2, just so that there is no integer overflow. Yes, in Python we shouldn't worry about that, but this is almost like a pseudocode. Then we need to check if if check if key works. Actually, let's change the name. Let's just do key works. I think here it will be nicer this way. Oh, actually, I think let's also rename this, because middle will be the specific key that we are trying to choose. So if key works of key, then we are trying to choose what. So key works. It means that we now need to set upper bound to key. Else, key doesn't work, and we need to set lower bound to key. And then we return, actually here we return, so here we will be returning upper bound. Will it be upper bound? So let's see, look at the invariant here, right? So we are pointing on the left. Left is always, no, we are returning the left bound. So left is always the smallest number that actually works. We will continue iterating until we will get like upper bound always points to something that, oh no, upper bound is pointing to something that works, and lower bound is pointing to something that doesn't work. Okay, I think this is correct. Now let's just figure out with a specific example. So let's use this one. 5 and 1 and 3 hours. So here the lower bound will be 1 and the upper bound will be 5 plus 1, so 6. Okay, so while L is smaller than 6 minus 1, yes, we do this. So first iteration, it will be 6 plus 1. Oh, I forgot that it should be clear division, integer division. So 1 plus 6, 7 divided by 2 is 3. So does 3 work? Okay, actually 3 is the perfect answer. Let's see how it goes. Keywords, let's see. So 3. The first call is 3. For pile and piles, 5 divided by, yeah, here I should have done this. Total hours plus or equal this. So it will be adding 5 divided by 3, which is 2. And then 1 divided by 3, which is 1. And total hours will be 3, and it will be smaller or equal, so it will be returning true. So if key works, then upper bound is equal to k, and we are updating upper bound to 3. Now we are continuing because L1 is smaller than 3 minus 1, which is 2. We are continuing. Cool. So now k will be 1 plus 3 divided by 2 is 2, and we are checking if k works. So with 2, we are dividing 5 by 2, it will be 3, 1 by 2, it will be 1. We are summing it up, it will be 4. It's not equal, so k doesn't work. So we update L, and now L becomes 2. So now we are out of this loop, and the left pointer points to a number that is smaller than our bound, and the right upper bound is pointing to one that works for us. So we are returning the right one. That's correct. Let's check if it works. It works. Okay. I have solved this incorrectly for one corner case, which is interesting. I haven't thought about something specific. So I have some big pile that is 31 million, no, 312 million, no, 31 million. 31 million, no, actually it's 300 million. Okay, yeah, 300 million, and we are dividing by, okay, 900 million, and my output is that we need at least 2 hours. This is a corner case that I didn't think about, or like I thought about this, but I thought it would work. So let's see what actually breaks here. So with this, with like some crazy big number of h. Okay, so max piles will be like 3 million, 300 million. So 300 million, this will be 1. Okay, key works. So even 1 is fine. Oh yeah, I know what was the issue. I need to choose different bounds. These bounds are incorrect because I'm choosing L as something that can never be chosen and L as something that can be chosen. Yeah. So here it won't change much. Yeah, L is always pointing to something that cannot be chosen. That was my mistake. Okay, good. Repeated a binary search. Thank you everyone for being with me today. This was a nice problem that we have solved in less than 20 minutes. So cheers, happy new year again, see you